Hello everyone, my name is James. Welcome to our brief tutorial on Modbus overview. In this video, we'll be covering some basics of various Modbus implementations. We also discuss on how Modbus works between field devices over different types of physical media and how Modbus can be used in a variety of applications. Thanks for joining me. Let's get started. We'll start with a brief history of Modbus to have some background information about why Modbus was created along with some application scenarios. Then we'll look at various Modbus implementations, such as Modbus Serial and Modbus TCP/IP. Next, we'll move on to a high-level overview of the system architecture by focusing on message formats. We also discuss about some interactions between a master device and a slave device in a Modbus network. Lastly, we will demonstrate the use of Modbus in a building automation system. Let's begin with the Modbus history. In the early 1960s, the production line systems of the car manufacturers were based on hardware relay logic. The control cabinet was huge and was filled with relays and motor controllers. The system was dependent on how relays and motor controllers were connected. If the control sequences of any process had to be changed due to a new car design, the entire system would be shut down and the rewiring process would have to be completed. In addition, if something went wrong, such as a faulty relay, then the entire system would have to be turned off in order to troubleshoot all this hardware logic. Therefore, in 1968, the first PLC was invented by Modicon. The programs of PLCs were able to be modified to change the way how the entire system operated without the rewiring process. In 1973, the development of the Modbus protocol made communications possible between PLCs to exchange data. Next, we'll look at some areas of Modbus application. Here's a typical scenario of a building automation application. The benefit of using Modbus is that Modbus connections between sensors and SCADA can be easily established over serial, Ethernet, and Wi-Fi networks. In this scenario, the water level in the water tank is maintained by the level sensor and the water pump. When the water drops below the predefined level, the level sensor will notify the PLC. The PLC will then instruct the variable frequency drive to increase the motor speed of the water pump in order to bring it back to the predefined level. The pump motor efficiency is measured by the water flow meter, which is used to reduce the average pump energy consumption. The Modbus serial network allows a variety of Modbus sensors, such as gas meter and electric meter, to monitor energy usage. All these measurements can be collected and displayed on the SCADA in order to prevent over energy consumption. Let's move on to Modbus implementation. The Modbus protocol is used by a wide range of automated equipment. The initial implementation was to adopt the existing RS-232 standard. It provided a point-to-point communication between a master device and a slave device. The main constraints of the RS-232 was the distance between a master device and a slave device. The distance was limited to less than 50 feet, and the number of devices was limited to one master and one slave. The Modbus organization encourages the adoption of the RS-485 standard if more than two devices, such as one master and two slaves, are connected on the same network. Let's look at the RS-485 standard. In order for a master device to communicate with multiple slaves, RS-485 is the most widely used communication standard. RS-485 is able to support 32 knots over a distance up to 4,000 feet. Additionally, it comes with two types of implementation, that is 2 wires versus 4 wires. The difference between 2-wire and 4-wire is the transmission mode, that is half duplex versus full duplex. Also, RS-485 support these two types of implementations. However, the Modbus communication protocol uses half duplex communications, since Modbus operates in a master and slave paradigm, in which only a master can initiate the request, then the slave will process the request and return some information back to the master. Next, we'll look at Modbus TCP/IP implementation. The implementation of Modbus TCP/IP is simply that the Modbus data are encapsulated in an Ethernet TCP/IP wrapper. You might be wondering why Modbus TCP/IP combines with Ethernet. It's because of the following similarity and benefits. First, both Modbus and Ethernet are supported by numerous manufacturers of industrial equipment. Second, there are no compatibility issues between Modbus TCP/IP and the already installed Ethernet infrastructure. Lastly, Ethernet communication offers faster data transfer rate than serial communication. Modbus TCP/IP uses the terms such as clients and server instead of masters and slaves. The difference between these terms is that in a serial communication network, normally we have one master and multiple slaves, whereas in an Ethernet network, we may have more than one client and multiple servers. Next, we will move on to the system architecture. There are two types of Modbus message formats. If Modbus is deployed over serial, then the ADU format will be used. The ADU format encapsulates a PDU unit by adding additional fields such as address and era check. If Modbus is deployed over Ethernet, the Modbus application header is added to the front of each PDU. The previous address field is replaced by the unit ID field, and the era check field is removed at the end. The Modbus application header consists of the following fields, that is transaction ID, protocol ID, length, and unit ID. The transaction ID is used to identify a query or a response message. The protocol ID refers to the Modbus protocol. The unit ID is used to identify a slave device such as a PLC. Next, we will look at the query response operation. A master device is responsible for querying all the slave devices. Each slave device receives a query message from a master device. A slave device will answer to a query by returning some data from its memory register requested by a master, or by writing some data into its memory. Let's move on to the live demo. The purpose of this demonstration is to illustrate how Modbus devices work in both file sprinkler and HVAC system. Typically, both systems are integrated into a building management system. Our network topology consists of these devices: a SCADA device, an Antaira industrial wireless IoT gateway, a PLC, an electric meter, and a temperature sensor. The SCADA, acting as a building management system, collects and displays data in real time. The wireless IoT gateway enables Modbus TCP/IP communication for these Modbus devices, such as the electric meter and the temperature sensor. The PLC controls the operation of fire pumps. The electric meter is used to record electricity usage, and the temperature sensor is used to measure the temperature of the surrounding environment. These measurement data can be further analyzed in order to improve energy efficiency of a building. Here's the dashboard of our SCADA, which displays the electricity usage and temperature. If there's a fire in a building, and if the water pressure drops below the predetermined level, then the fire pump will be switched on to make sure that the water from the water tank can be pumped into the hydrant pipes in order to extinguish the fire via sprinklers. Next, we will present a live demonstration. This demonstration illustrates the use of Modbus in both HVAC and fire sprinkler systems. Our scenario consists of an electric meter, a temperature sensor, a PLC control panel that simulates the operation of both fire pumps, a wireless IoT gateway that converts the Modbus serial to Modbus TCP/IP. Lastly, we have a SCADA device that displays data in real time. The electric usage and the temperature can be used as a reference for reducing carbon emissions in order to improve the energy efficiency of a building. If there is a fire in a building and if the water pressure drops below the predetermined level, then the first pump will be activated. Lastly, the second pump can also be activated through SCADA device. Thanks for watching our video, and see you next time.